We're going to do a similar problem to example 1, but the whole point of finding inverses is they can be used to help us solve systems of equations using inverses. So the way this works is if I have a system of equations that I can write as a set of two matrices, and on the system of equations that I'm showing down here, we usually call the first matrix A. That's going to be the left side of the equal sign, so -1, -1, 7, and 6. And then I'm going to have this matrix B that is the 1 by 2 matrix of the answers. So here's the idea. If I can find the inverse of A, and we can because we just did it in the previous example, and I multiply it by the matrix B, I'm going to get my solutions, the numbers for x, y. So we're going to do that on this next problem. So A is that, and I'm going to set it up here. All right, -1, -1, and 7, 6. And on the other side, I'm just going to have the identity matrix. Now I'm going to work on solving this. Actually, I'm going to work on getting the left-hand side of this to look like the identity matrix. And the first thing I notice is, so again, I'm working on column 1, and I need to turn column 1 on the left matrix into a 1 and a 0. So the first thing I notice is I've got a -1. So if I multiply this equation by -1, I'm going to get a 1 where I want it, the first column, first row. Happen to also get a 1 there, and then I multiply by -1, I get a -1 on the right-hand side and a 0. So matrix, so my new matrix, I replaced row 1 with the multiplication by -1. Okay, now I need in row 2, column 1, I need a 0 instead of that 7. I'm going to use row 1, and I'm going to multiply it by a -7. And then I'm going to combine it with row 2 to get a better row 2. So -7, -7, -7, +7, and 0. And I'm going to just copy over row 2. And my new and improved 2 is 0, which is what I want, -1, 7, and 1. Okay, so on the left-hand side, I have the new row 2 replaced, and what I need in row 1, column 2 is a 0. If I combine row 1 with row 2, I will get a 0. So I'm just going to take this out. Little workspace here. And my new row 2 is going to be 1, 0, 6, 1. So my new and improved matrix has my new row. You know what, I made a mistake. This is my new row 1, which is good because that's where I wrote it. Now looking down at row 2, column 2, I need a +1, and I have a -1. So the easiest way to do that is just to multiply that whole row by -1. Okay, that goes positive, and then my 7 goes negative, and so does the 1 on the other side. 1, 0, 6, 1, 0, 1, negative 7, 1. Okay. So the inverse of A, and by the way, we write it this way, A to the negative 1. Did I write it that way at the top? Yes. That negative 1 just means that A is the inverse of the original A, is 6, 1, negative 7, 1. And I'm going to multiply that by B, which was negative 2, 1. And the result will give me the XY pair that solves the system of equations. Remind myself that I go by rows here and columns there. So the result of my multiplication is going to be 6 times negative 2, negative 12, plus 1 times 1, which is negative 11. That's fine. And then my second solution is going to be negative 7 times negative 2. That's a positive 14, plus 1 times 1, which gives me a positive 15. There's my solution. So x equals negative 11, y equals 15. If you don't believe me, you can plug it into the equation. All right, that's it for this video.